Hey everyone, welcome back to my daily coding series. Today is day 59. So we're going to look at, I just did a bunch of static problems yesterday, so today I'm going to look at, I guess I'm going to continue with the roadmap and look at 2D dynamic programming. So yeah, I don't really expect to solve it because it's pretty tricky. I could also do advanced graphs, but we'll just look at unique paths today. So I've never looked at this before. So we have a grid where you can move down, right, down or right. Given the two integers m and n, return the number of possible unique paths that can be taken from the top left corner to the bottom right corner. Okay, and we can either go down or right. Okay, so my initial thought, so if we have a grid, so what is this, 6 by 3. So I'll just draw circles, 2, 3, 1, 2, 3, 1, 2. Okay, so my initial thought would be that, so we know that from this point, there is 0. Okay, so we need to turn the number of unique possible paths. So there's only 0 possible paths from here. From here, there's only 1 possible path. Same with here. From here, there's only 1 possible path. From here, there's only 1 possible path. So we know that this only has 1 possible path, all of these. If there's a 1, if there's 2 1s, then we know that there's 2 possible paths. You could go this way or this way. What about here? If there's a 1 and a 2, then we'd say there's 3 possible paths, because from this point you can go this way, or this way. So there's 3 possible paths. You can't go that way because you can't go left. Here would be, so now this is a bit tricky, because it's almost like we have to know this one. Well, no, we can't go up. Oh, okay. So we can't go up, so we can just determine this by adding the bottom and the right. So this would be 3. Here would be 4, right? Because this way has 3. So let's think. There's 1, 2, or 3. So here you can go, there's 1 there, or you can do all of those 3. Here would be 5, I guess. Same reason. Here would be 6. This one would be 6. This one would be 10. This would be 15. And this would be 21. Awesome. So I think that's kind of how you can do it. Great. Yeah, I think that makes perfect sense. So we just assume that this would be, there's 0 ways, and then we can start. Well, I think a good strategy would be to make this whole like reverse L shape be 1s, because from every path there's only 1 way you can go, and then we'll just go like this and sum up the dp of below it plus the dp to the right of it. And I think that makes sense. Yeah, I don't know. I just kind of, with dynamic programming, usually you want to start from what you know. So I know, like, hey, here there's 0, here there's 1, and then you can kind of just use that information and go from there. So I'm going to make an array called dp, and I guess we'll say for whatever in range m, and then so we could say like row. So m is the number of rows. So could we say row dot append n, and then when we're done, so we'd say like, so I basically have to build a 2D array. So I should look up the best way to do this. Maybe I could say dp equals a list I for I in range. Or maybe we could say, all right, so what's one list? So with a 2D array, it has m elements, and each element has n. So if we do the inner one first, let's say 0 times n, and then we want to do this times m. But the only problem with this is we'd have to do dot copy, I think, because, or else we would just be repeating this same pointer m times. So let me print dp. Okay, so it's 6 by 3. That looks good. And if I change, if I were to say dp of 0, 0 equals 9, then that should not change the other ones. Okay, so it does change the other ones. Yeah, so I was worried about that. So maybe we don't want that. Maybe we want that. No, we have to make it a list of lists. So I thought the dot copy would, I guess we could say dp equals empty list and then 3 times. So in range m, we can add dp dot append a new list of 0 times n. Okay, looks good. So now we can see only the first 9 changed, and that's because this is a unique list and we're not duplicating that list m times. So we're kind of, we're creating 3 separate pointers. All right, that looks pretty good. I think this way of making a list, is a 2D array, is pretty sufficient. Okay, so we're going to initialize them all to 0. Maybe we can initialize them to -1, I guess. Okay, so now what we want to do is make all, so first of all, dp of n, well maybe it's, so in this case m is 3, so dp of m minus 1, n minus 1 equals 0. So we're going to set this to 0. And then we're going to set all of these. So I could say if, yeah, I'm not going to do that. Okay, so we're going to set this one to 0 last. So let's make last row all ones, and then make last column all ones. So we could say for I in so we're going to make the last row all ones. So how we would do that is how? Well, maybe we could do times n minus 1 plus 1. Let me see that. So I'm thinking that we'll add 1 as the last element. Yeah, so 1, 1, 0, that's perfect. And then we want these to be all ones as well. So we can do that by saying if I does not equal m minus 1, then we'll do that. Otherwise, we can dp dot append ones times n. And then we can just overwrite. Well, I guess to keep it consistent, we can say plus 0. Okay, so this should give us our starting dp. Yeah, so 1, 1, and all 1s and 0. Okay, so that's our starting DP. So I'll just say like initialize DP array. Okay, so now what we want to do is loop starting here, going there, and going there. So I want to go through the rows backwards. So I think 4i in range m minus 1 minus 1 minus 1 or something, and then 4j in range n minus 1 minus 1 minus 1. Let me just print ij. So I'm going to try to get the right indices, and then once I have that, I can just go through and adjust the DP array. So let's look here. So we have 2, 5, 0, 1, 2. So I think we want this to be, we don't want to, so we want to start at, so I have m minus 1. So that would be 3. So we want to start at 1. And then I think the same with this, because we don't want to include, we've already done the last row. Okay, so 1, 4, that would be row 1, column 0, 1, 2, 3, 4, 1, 3, 1, 2, 0, 4. Okay, it looks perfect. So what we're going to do is update DP array to be sum of below and right. So we would say dp of ij equals the one below you. So that's I plus 1 j plus the one to the right of you, which is I and j plus 1. And then we want to return dp of 0, 0. So that's kind of how I did it there. Let's see if that works. Okay, a little edge case there. Okay, so there's a couple of edge cases I want to consider. So I think we got the general solution. A couple of edge cases that I want to consider is if n or m equals 1. So if you have like a box with just 0 in it, then how does our code react? So m is 1 and n is 1. So our code says it'll do this. So it'll append 1 times 0 plus 0. Let me just print at this stage what dp equals. So I could just add an if statement at the beginning, which I might end up doing. But just to be, okay, so the dp looks good. My output is 0. But it's expected to be 1. Why is it? Oh, I'm saying that there's 0 path. Should I assume that there's... Should I assume that I deleted it? But I guess maybe I should assume that this right here is 1 path. Instead, because I guess if you start here, there's one way to get to the end. So I can just do this, perhaps. I don't really need these parentheses. Okay, let's see if that works. Okay, there we go. Okay, wow. I thought that was going to be a lot different. I'm glad that I was able to just think of that on the spot. I took a class where we did... So I saw that the next problem is called longest common subsequence. So some of my classes have talked about this, longest common subsequence, and it kind of reminded me of this problem a bit. So I was able to kind of map that a little bit. So let's go ahead and look how it does on LeetCode. So it's called unique paths. All right, bring it over. So I'll try this solution and see how it does. Got a little robot there. Okay, nice. So it's not, there's definitely better ways to do it, it seems. Yeah, there might be some trick. Well, I guess we don't need to store the whole array. Because maybe what you could do is just do like this and then like just do it layer by layer, so you only have to store like some information. So you don't have to like keep like, because once you have all of these numbers, you no longer need to know the ones, and you might not even need the ones at all. You might just say like, if it's out of bounds, then just add 1 to it. So I could definitely do those, but I feel like the essence of the solution is captured here. I don't need to print anything either. I don't know if that was taking up a lot of time. Oh, whoops. Oh, yep, it looks like it was the printing. Okay. Yeah, so it was actually just the printing. But I think those optimizations I was talking about would still work. Yeah, just so you guys know, if you ever print anything in your program, it's like extremely time consuming. So just remember to take those out. And yeah, so that was a good episode. I'm happy about how that went. And thank you very much for watching. See you tomorrow for day 60, I think.